I'm doing the introduction.
Give it about 10 seconds to get the live stream going.
Okay.
I'll drop the live stream link when it's
Thanks a lot.
Okay, you're live. Okay,
super. Thanks a lot. So, hi everybody. This is Hyperledger Budapest. This is a meetup from Linux Foundation, focusing actually on the consortium blockchain technology. And it's basically a free knowledge sharing meetup. So everybody is welcome to bring any topic, related to consortium blockchains. Of course, especially products of the Hyperledger umbrella and incubation. We're gonna have today two presentations. The first is from György Balázsi, independent digital strategy consultant and Daml expert. He's gonna have actually a very good presentation on the possibilities of having Daml as a rapid application development tool instead of Fabric Composer. And the second presentation will be done by me. It will be something a little bit deep dive. Not so deep, but deeper than healthy, I would say. So deep dive into the Fabric keys and certificates and access control and stuffs like that. So this was actually the brief presentation. I hope people wanting to see this meetup joining slowly. So I would say I would give the stage for György, and then György, the stage, the floor is yours.
Thank you very much. I would start sharing my screen if it was possible. So can you give me the right to share my screen?
You should be able to share. The previous person needs to unshare first. So
okay,
Daniel unshared.
No, it's good. Okay, so my name is György Balázsi, and the topic will be the Fabric Composer, what its design principles and ambitions was. Why was it relevant and why is it still relevant? I'm using past tense because it has been deprecated a few years ago. It was a relatively short-lived project, but its existence proves that there is something important the people behind this project tried to fulfill. And I'm comparing the promise of this Fabric Composer platform to a relatively new other platform, which is a smart contract platform called Daml, D-A-M-L. And I also have among us a community manager from the company behind Daml, Anthony Lusardi. He promised me to help out with questions, so he will interrupt me when he sees that there are relevant questions in the chat. So please type your questions on the fly to the chat, and Anthony will help us to time the answers.
Yeah, sure.
Yes? Okay.
Oh, so no, I said I sure will. I'm just practicing interrupting you now for later.
Okay, thank you. I have prepared a few demo files. You will be able to find these in this GitHub repo. And then I start. So as a summary of my message, so there was this Fabric Composer platform, which was has had the mission to make it easy to build distributed business applications. And I think On one hand, it's a sad thing that it has been deprecated, but it has shown us an important development area. And I think the promise of Composer is fulfilled by the Daml smart contract platform, which is which can also be used on top of Hyperledger Fabric and many other blockchains and centralized databases as well. The company behind Daml is no stranger to the Hyperledger project. They donated actually the name Hyperledger and the original code base of Fabric to the project. And DA is also not stranger to Budapest. They have an office here among other locations worldwide. So my storyline will be, I will elaborate on my specific POV, my specific point of view, because it might be different from yours, and because your perspective is your reality, it might mean that you see things differently than I see. But I think this point of view is relevant in this topic because it seems to be very similar to the people who created the Fabric Composer framework. I will be a bit speaking a bit about what are distributed applications. So I would like to stress a few aspects of distributed applications, because this is the super category of the platforms we are speaking about, like blockchain, distributed ledger technology. Then I will elaborate on a bit more detail what actually the Fabric Composer was. For those of you who don't know that platform or didn't use that platform or don't remember so well what it was and how it was used. And then I will come to the most exciting part of my presentation, at least for me. So I will do some live coding, and I will demonstrate one key feature of the Daml smart contract platform. This is the propose accept pattern, and I will show you how we can create real contract-like objects in Daml, actually signed by several parties. And then I will show you which are the platforms on which Daml can be used. One of them is Fabric, but there are several other platforms as mentioned, and you can ask questions then, or Anthony will see the comments. Maybe he will interrupt me on the fly. So my specific point of view. So some of you might be enterprise architects, I think, and some of you, and those people who are working as enterprise architects think in terms of containerization, orchestration, event sourcing, reactive programming, certificate authority, as Daniel will elaborate on. But my point of view is something slightly different and is closer to the business applications. So I would say I'm an economic network architect. So my goal is to implement transaction networks which encompass several companies or government agencies. And I like to think in terms of economic networks, need-to-know basis, GDPR, within that specifically the right to be forgotten, principle, and delivery versus payment, power of attorney, and things like that. So this perspective is, as mentioned, more it's closer to the business needs, and it represents another abstraction layer than the typical concerns of enterprise architects. And as mentioned, I think this perspective is similar to the perspective of the people behind Composer. So what are distributed applications? My next question. So if you think about it, distributed applications are older than computers or computer networks or the internet. So I would even say distributed applications are as old as mankind. So businesses are over distributed. So if you think about it, when you sign a contract, you never sign a contract in one copy. You always sign several copies, and identical copies of the same contract get signed by several stakeholders or counterparties, and these paper contracts we are speaking about before the computer age. So these paper contracts get distributed among the stakeholders and make up a kind of virtual shared ledger together. On the left hand side of this slide, I have put an interesting picture. This is a mechanical device which was used by President Jefferson, and it's called a polygraph. And he used this for the purpose of copying every outgoing letter, so that he can preserve a copy of the letters he has sent. And this virtual shared ledger, which consists of contract copies, is supported by the judicial system, so it doesn't stand in itself, so it is part of a system of institutions as well. So when we switch from paper to digital, then things get more interesting for us, because we are IT experts and we think in terms of IT systems. And I would like to emphasize one important aspect of distributed applications, namely that there is a clear distinction between what is inside and what is outside of this this network or a distributed application, or as it's called on this diagram, a virtual shared ledger. And it's important that the client applications which are connected to the network or the distributed applications are not part of this application, that they are not controlled by the network itself. So they can even be adversary. The network or the shared ledger or distributed application itself provides the users with pair-party views, which are not necessarily identical to each other. So it's usually not the same. So the privacy rules dictate different projections of the same information to several participants. Examples of these kind of distributed IT systems already, I'm not speaking about anymore about paper contract systems. Such IT systems are stock exchange, online poker, supply chain, and there are a lot other examples. So now I'm coming to the point of what was the purpose and the design principle of this Fabric Composer. And before going to that, I would like to share a view, my experience on how usually the standalone Fabric platform is used. So the standalone Fabric platform, in terms of application development, provides two basic functions. This is get state to read the state of the ledger and put state to write the state of the ledger. And basically, everything else must be written from scratch in terms of chain code, which implements the direct connection with the ledger, and client applications which are at the other side of the API. And I have the observation that the standalone Fabric is typically used as I would say, a registered digital tube mail. So it is used to usually to move information from one participant to another, or more other participants in a safe and controlled and auditable way. And the transaction logic is often implemented client side, which I think is a problem because of what I have emphasized formerly about distributed applications. So if we put substantial parts of the business logic outside of the common application, so the client side, we cannot be really sure that these client applications operate in concert with the distributed common application. So there seems to be a missing piece or a missing link here between the IT platform and the business applications, and it seems that the people behind Fabric Composer felt this missing link, and they wanted to create a platform which fills in this missing link between the Fabric platform itself, the IT platform, and the business.
György,
yes?
Arnold had a comment in the chat, I think in respect to some logic ending up in client applications. And they said that it's clearly not always true. It's up to the application and chain code developers. Can you maybe talk a little bit about that?
Could you repeat the question, please?
Yeah, they said it's clearly not always true that some of the logic would end up, if I'm understanding correctly, if some of the logic would end up in the client application, it's up to the application and chain code developers, essentially.
Yes, that's true, of course. I'm not stating that this is always true, that the transaction logic is implemented client side, but I have seen several examples for that, and I have seen several applications where the Fabric platform itself was only used for like a notary service. So I'm not stating this is always the case, but there's a tendency for that, I think.
Yeah, I think to your point, you're just saying that Daml makes these separations of concerns a lot more explicit, which I think is very useful. And it kind of encourages developers down a happier path, I would say.
Yes. Yes, thank you.
Oh, and Greg had just asked, isn't Composer deprecated?
Yes. So this diagram was taken from a presentation from the early days of the Composer platform, and it shows how the underlying Fabric network is extended by this upper layer. So the underlying Fabric infrastructure uses concepts like key value store, chain code, peers, consensus, and the layer built on top of that consists already of business abstractions like participant identity, assets. Like in this, so this example represents a car auction network where we have cars as assets and car listings when the owner offers up the car for an auction. So these are the main basic assets, and the participants are the car owner who can list the car. We have potential buyers who make offer for the car, and the auctioneer who conducts who organizes this whole auction. So these kind of business so we are speaking about these kind of business networks, and so I find important the abstractions. So so these are the kind of business related or business friendly abstractions that were supported by the Fabric Composer platform and are also supported by the Daml smart contract platform. So there was actually one aspect of this Fabric Composer framework which was not so much convenient, namely that you had to create several files with several syntaxes in order to implement this kind of business network. So there is a model file which contains the assets, the participants, the transactions. There is a separate file which in which you had to actually write in JavaScript the transaction functions. And there was a third separate file which consisted of the access control rules, which regulate who can do what. So who among these participants can do what with these assets listed in the model file. And there was no very convenient way of checking the consistency of these files. And in this respect, at least, Daml seems to be more convenient because, as I will show you, you can put all these things in one consistent syntax, and you have consistency checks in terms of type checking. So actually, you can find the original files of these car auction network in a GitHub repo. So you can see I have also I can also show you how these files look like in reality. So for this car auction network, this is the model file, and you can specify participants and assets in an object-oriented manner. You can, as in many other programming languages, as fields of an object, and you can also specify links between several kinds of assets and participants. So the other file is the actual JavaScript code, which implements those transactions which are listed in the model file. In this case, there are two transactions, offer and close bidding, and the actual functions which implement these transactions had to be written separately in this JavaScript file. And the third part of the system is an access control file, which is another different syntax where you could specify these access control rules, where it is stated which participants can do what with which resources. So in this case, for instance, a member, so what a member can do with a resource which is a vehicle. So this is how this platform worked, and I was doing some research about why actually it was deprecated, and I have found an interesting document for this. This was a Composer technical steering committee update, and it explains in detail what the design principles and the reasons for deprecating of this platform were. And interestingly, one of the so there were two main goals of this platform. One of them was to improve developer experience, which I think they could pull off, and they also set a big goal because they wanted to support multiple blockchains, not just Hyperledger Fabric. And another nice thing about Fabric Composer was that unlike Fabric, it had a REST API, which the standalone Fabric platform doesn't have. And as a result of Fabric Composer, there were many POCs, but as the authors have stated, there were few production applications which were created using this platform, and they identified two problems behind that, and one of them was that in parallel to the standalone Fabric, the Composer represented a different programming model, and many developers thought that they have to choose one or the other, and many programmers choose the traditional Fabric chain code development programming model. And the other reason and the other problem which led ultimately to the deprecation of the platform was that it turned out to be difficult to keep up with Fabric features, e.g. the private collection features of Hyperledger Fabric. So this is what I was bringing up with the Fabric Composer, and now I I'm coming to the point where I'm going to show you the alternative or the platform which I think can be a good substitute of this business friendly application development platform. And now I will go to some live coding. So I have to say I've never done this before, and I'm very excited to do that. I did a few rehearsals, and I hope I won't do many mistakes. So the focus of this live coding session will be that I will show you how on this Daml platform you can implement contracts which are signed by several parties. And before doing that, I want to mention some general general features of this smart contract mental model which is behind the Daml platform. So in Daml, the basic concepts we have are parties, like in Fabric Composer, and the platform is very much focusing on implementing rights and obligations, and its ambition is to implement the principles of contract law and a privacy model together with that, which is the need-to-know basis, so that information is only disclosed to those parties who actually have to do something with that information. Other details of the Daml ledger model you can read in the Daml ledger model section of the Daml documentation. And now I actually come to the live demo, and now I would like to show you how we can implement an agreement contract, which I already started to write in this file. And so this is how, in general, a Daml contract template looks like. Maybe it's a missing piece of information that in Daml we have a different terminology from, let's say, Ethereum. So in Daml we call contract the actual piece of ledger items which are created based on Daml templates, and the Daml code consists of these contract templates. And so when writing Daml code, we often write the contract templates alongside with scripts which actually demonstrate and test how the ledger transactions based on these contract templates look like, and what the result of these ledger transactions will be. So in the background, so what you can see here is called the Daml Studio. This is a VS Code extension, and in the background of this, a ledger sandbox is running, which simulates the ledger transaction validation, and the error messages signal the fact when a ledger transaction would be rejected by an actual Daml ledger. And what we can see here is that I started to write an agreement template, for a very simple contract. This contract only says that we have two parties. We have party A and party B. the contract should be signed by party A and party B in order to be created. And it only says, it only has an agreement text, which is a parametric text. And when the contract is created, the text says that in our case, Alice and Bob are good friends. So this is a very, very basic contract template, but we have a problem with that. So this red sign and the error message state that this that the creation of this contract, which is written here in this line. So this line states that Alice wants to submit a create transaction with the parameters stating that the party A of the agreement should be Alice and the party B parameter of the contract should be Bob. And the contract template states that the...
György, can you just
yes.
make the text a little bigger? It's actually a little hard to see.
Okay, appearance. Okay, is it better now?
Yeah, that's a bit better.
Or shall I try even more? Okay. So, as stated, we are demonstrating alongside with writing the contract template with a script, and we have allocated the parties on the ledger called Alice, Bob, and Carol, and we have stated that we call Alice party A, we call Bob party B, and Carol party C. And this is the line which says that Alice tries to create this agreement with these parameters, party A equals Alice, party B equals Bob. And we have this error message stating that this transaction is rejected by the ledger because Bob's authorization is missing, which is quite understandable. We can try to improve the situation if we delete from the template that this contract needs the authorization of Bob. And in this case, we can see that actually the ledger would accept this transaction and would create this agreement contract. But the problem is that this is not the contract we want to see, because this is not a contract signed by two parties. This is just signed by one party. And this dilemma seems to be very difficult because we have the challenge of signing a contract by two different parties. And what the Daml platform offers as a solution is this propose accept pattern. And for this, I need to create another contract template, which is a template, which is a proposal contract with basically the same parameters. And I put back here, so the agreement contract should be also signed by party B. And now we have a proposal template and an agreement template. And in the script, if we change the template name from agreement to proposal, then we can see that Alice actually can create this proposal contract. And this can be seen on this part of the screen. So actually, this Daml Studio has the nice feature that it actually shows you the result of ledger transaction proposals. or attempts. Now we have a valid proposal contract and an agreement contract which we would like to create. But we have the challenge to connect these two things together, and the Daml solution to this is that we can put so-called choices into Daml contracts, and we can extend the proposal contract template so that we say that we will have a choice which has a controller. So controller party B, which will be Bob, can do something. The name of the choice which will be exercised is proposal underscore accept. This is a convention which indicates that we are defining a choice on the proposal contract which with the content of accepting this proposal. And we also have to specify the return type of this choice. And the return type is usually a contract ID of the created contract. And we want the agreement contract to be created. So this is the choice name and return type. And what the choice actually does, we put into a so-called do block. And in this case, the result of exercising this choice will be simply creating an agreement contract with the parameters which are already specified. So we want to be created this agreement contract so that the party A parameter of the agreement contract shall be identical with the party A parameter of the proposal contract, and the party B field should be identical with the value of the party B parameter of the proposal contract. And now we can see in the result screen that actually, okay, we cannot see because I didn't extend the script yet. So we can see here just the first step, that the proposal contract has already been created as a result of Alice creating it. And now we put here another step, which means that submit Bob. In this case, this will not be a create command, but an exercise command. We have to specify which is the contract on which we exercise the choice, and that will be the proposal contract we have just created. And we also have to specify the choice which will be exercised by Bob, and this is the proposal accept choice. And now we can see that the result of these two steps, so in these scripts, these are the emulation of two ledger transactions. We can see that as a result of these two steps, an agreement contract has been created instead of the proposal contract, which was the first step. And if we want to see the evolution of the contracts, we can also specify that we want to see the archived contracts. And in this case, with this setting, we can make visible that there was actually the proposal contract before the second step, but it has already been archived. And there is another interesting option in this screen, namely, we can specify that we want to see the detailed disclosure of these contracts. And the disclosure can be seen in this part of these tables. And this shows that the proposal contract was signed by Alice. So Alice was a signatory. This is something we knew because this is how we created the script. And Bob was an observer on this contract. We didn't specify this, but we specified that Bob should be a controller of a choice on this contract. And this is why the Daml platform makes Bob automatically observer on this contract. And I'm going to show you another interesting part of this disclosure mechanism, because this kind of observer is called implicit observer on the Daml platform, but we can specify observers explicitly. So I specify a third party on this proposal contract. And I will say that this third party, which will be Carol, this third party should be an observer on this contract. And we can see what happens. With this double dot shorthand, we already made sure that Carol will be substituted in the place of party C at the creation of this proposal contract. So that's why we can see here Carol, and not only here, but in the proposal contracts, we can see that Carol was also an observer, just like Bob, but it's a different situation because Carol is not an implicit observer, but an explicit observer. We explicitly told in the contract template that we want this proposal contract this close to Carol. But there is an interesting consequence of this observer status, because in the agreement contract template, we didn't say anything about Carol. We didn't say in the agreement contract template that we want Carol to be an observer of the contract instance, but due to the privacy model of the Daml platform, Carol was made automatically observer of this the created agreement platform. More specifically, not an observer, but a witness. And this is called witness because it's neither an implicit observer nor an explicit observer. It's the witness. It's actually so she's actually the witness of the creation of this contract, and that's why she can also see the next stage of the evolution of this contract process. And I don't want to spend more time with this live demo, but the next question would be, if we wanted to spend more time on this proposed exit pattern, that okay, we know now how to create a contract which is signed by two parties, but how we archive a contract which has been signed by two parties. Because I will show that to you that the naive method won't work, so we cannot archive this contract in a simple way. So let this be the agreement CID, which is the contract ID of the created agreement contract. And let's try submit Alice archive command this agreement CID, and we will see actually an error message which state that this transaction would be rejected by a Daml ledger because Bob, who is also a signatory of the agreement contract, didn't authorize the archival of this contract. So I think I spent a bit too much time so far. This is a diagram showing this two-step process we have seen in detail in the developer environment. So this shows that the creation of this agreement process happened in two steps. First, Alice created a proposal contract. In the second step, Bob exercised a choice on this proposal contract. And as a result of these two steps, an agreement contract was created where signatory is Alice and Bob at the same time. And what you can see on this diagram is that the way we could implement the archival of this agreement contract, that we could specify choices for Alice and Bob so that they can archive the contract unilaterally. Okay, so this was the propose accept pattern of the Daml platform, and now I continue with information about which underlying ledgers can support the Daml smart contract platform. These are several blockchain platforms, among them Hyperledger Fabric, Hyperledger Saltus, Hyperledger Besu, which is the enterprise Ethereum client. It's also supported by Corda, VMware blockchain, and this BSN is stands for the Chinese nationwide blockchain platform, which has been created last year maybe. And in this list you can also see centralized ledgers or simple relational databases. So you can use the Daml smart contract platform with Amazon Aurora and Amazon Quantum Ledger database as well. And PostgreSQL is not listed in this list, but it's also available. And there is a cloud-based ledger as a service developed and maintained by Digital Asset, where you can also use Daml based applications. And so the beauty of this portability is that you can create Daml models without actually deciding which underlying platform you want to use eventually. So you can start with a sandbox test environment, then you can deploy it on a simple relational database, and later, if you find it necessary, you can port your application to a distributed blockchain platform. This is the architecture diagram of the Daml Fabric platform. You can check it out for yourself. And now, please ask questions. Sorry for Daniel, but he mentioned that I can be liberal with time, so he will not be upset if we spend a little bit more time with my
György,
60.
Greg was asking if anything was on GCP, which I think would be Google Cloud Platform.
Google Cloud Platform, I think, but please correct me if I'm wrong. The Daml-based applications can be deployed on several cloud platforms, including Google. I don't know about any special support on behalf of GCP, but you can deploy basically
GCP
anything.
does have Postgres support, so you could definitely do Daml on GCP over Postgres, and probably other things too, because you can probably host whatever you want on GCP.
Yes, yes, I think
Fabric you can. Yeah.
Yeah, the Daml platform doesn't have any special requirements. So Daml runs on Java virtual machine, and you can use it on any platform which supports JVM, which is, I think, all IT platforms. Do we have other questions?
Thank you.
So no other questions?
No, no other questions at the moment.
Okay, so I would leave you with a few hints about possible next steps. If you found this topic interesting, I would recommend to check out the Why Daml section of the Daml website. It's an excellent summary of the design principles and the application potential of the Daml platform. So I would recommend this as a first read, definitely. Then you can try Daml online. So they have an online playground where you can play around basically the same way as you can do in the VS Code Daml Studio I was showing to you. Next step, if you are even more interested, download Daml Connect, which is the Daml platform, the Daml SDK. You can learn about Daml in interactive tutorials. You can try for yourself the Daml on Fabric driver, and as mentioned, Digital Asset is also already maintaining a cloud-based ledger as a service platform, which is called Daml Hub, and this is also a potential deployment target. And the interesting part of this Daml Hub is that, as far as I know, this is the only platform where actually the Daml smart contract package is transparent for the users. So if you use this platform, you can actually see with your own eyes what is the underlying Daml package, which specifies the transactions, and it's an excellent opportunity to audit Daml-based applications. So thank you very much. It was so much I wanted to share with you, and I hand back to Daniel.
Super awesome. Thanks a lot for the great presentation. Is there perhaps any question regarding to Daml or Daml on Fabric from the audience? So I can see just the chat at the moment, but actually there's not much going on. So if no more question, then I would propose I would just switch back to the general introduction, and where basically the next presentation is from me. It was planned to have a deep dive into Fabric certificates, but I would say, so it's a big topic, and then due to time limit, it will be just a brief dive into the topic. I can share video for a second, but I've been working in home office for more than a year, so I don't look well. So I just stop sharing my video, and then I concentrate on the focus. So if we want to understand Hyperledger Fabric and Hyperledger certificates, then we have to be aware of a couple of things. So basically, Fabric is something which is called an enterprise system. Enterprise system is something that is capable to cover many different scenarios, which means it can be set up with many different enterprise requirements. It is, of course, an advantage, but the problem, of course, is always that then it gives some complexity to the system. So it's not always very simple to set up, even in simple scenarios. The basic idea of Hyperledger Fabric, and actually for most of the blockchain is the digital signature. So usually there's the question, hey, we got blockchain. It has a lot of cryptography, so it makes some secrecy as well. But this is usually a misconception. So basically, blockchains do not really provide secrecy, do not really provide privacy. There are some ongoing investigations as well. But basically, blockchains do have a lot of cryptography. But this cryptography is usually digital signature and has hash functions. Most of the blockchains do not have built-in privacy concepts as cryptography, as secrecy, as encryption. So the basic idea is digital signature. I mean, digital signature looks that way. We got like Alice and Bob in this slide. So basically, Alice has a private key. She can sign with this private key. Bob having basically Alice's public key. And then if Alice signs something with her private key and Bob having the public key from Alice, then he can verify if the document or usually transaction or communication way was really signed by Alice. So that's the basic idea of digital signature. We get like two common crypto systems. One is basically it's based on the RSA system.
Hey,
so
Daniel,
yeah.
In chat they're saying that the voice is a little loud and distorted. Could you maybe turn down the volume on your microphone a little bit?
Okay, yeah, that might be a problem. Or if I just
that's much better.
Stop shouting, that might help as well. Is it better now?
No worries, you're enthusiastic.
Yeah, okay, I got the point. So let me just take a look. So basically, we got like two big arithmetic systems or cryptography systems. One is basically RSA. RSA is based on it's like, it's a clock arithmetic. So this is like 12 o'clock. This is like 6 o'clock and so on. So the basic idea is something similar, that we got a one-way function, which can be computed very easily in one way, but it's much more difficult to compute in another way. So like if we get this modulo arithmetic, then I mean, having something in a modular arithmetic like multiplication is something which can be very easily computed in one direction, but based on like a multiplication, implicating back to the original numbers is difficult. So this is a one-way function, easy to compute in one way, but even more difficult or very difficult to compute in another way. It's actually not an NP complete problem, but it is supposed to be very difficult to compute in a reverse direction. And we got another one, so we don't have RSA in Hyperledger Fabric. We got something as an elliptic curve digital signature and elliptic curve cryptography. So elliptic curve cryptography has something similar ideas. So basically, this is your elliptic curve, and we can define some operations on that, like addition and multiplication. So like addition is something, you get 2 points, you get one line, and this is the third point. So if this is A and this is B, then this is A plus B. We get something as multiplication as well. Multiplication is this is like, if this is key, then this is -2 key, and actually this is 2 key. So I'm not gonna go very much into the details. The idea is basically the same. So we iterate somehow on this elliptic curve in a way that it can be computed very easily in one way. So like multiplicating something several times is easy to compute, but based on the multiplication implicating back to the original numbers is difficult. So basically,
Daniel,
that's somehow the idea of.
Greg has a question. Is RSA also in Bitcoin, or is this a Bitcoin concept as well?
As far as I know, there's no RSA in Bitcoin. Bitcoin uses elliptic cryptography as well.
Yeah, I think it's SECP.
Yeah, exactly.
Whatever. Yeah,
exactly. So for some reason, I don't know any of the blockchains that uses basically RSA. Bitcoin uses elliptic curve cryptography, and there's one more. I think one more stuff. There's an explicit hash function in the address generation of Bitcoin, and the reason is for that because it makes the system more quantum computing resistance. The problem is both from elliptic curve cryptography and RSA that they are not resistant for quantum computing. So you can easily compute both stuffs, both algorithms, with the help of like quantum computer from like 1,500 bits.
Greg is asking, is that an ellipsis curve on the screen?
Sorry. So this one is an elliptic curve. I mean, as far as I can draw it. So this one is an elliptic curve. I'm not very good at drawing something, but this is supposed to be something as an elliptic curve. Okay, the green one. So I got probably a better. So this one is a better one. This is the red one, and this is the elliptic curve actually on my slide. And then you get here the addition actually. So it's like P plus Q equals minus R. No, sorry, R, I guess, or minus R, and this one is the R. So actually,
Greg's asking if there's a quantum computer that can break these elliptic curve algorithms.
So as far as I know, not at the moment. The point is that you can break simple RSA algorithms from 1,000 to 1,500 qubits. And as far as we know, then the biggest quantum computer is something like 100 qubits. So we still have time in this sense, but who knows? Perhaps somewhere in secure military complex, there's even more quantum computing. But again, the state of the art is that RSA can be broken from 1,000 to 1,500 qubits. Elliptic curve might be or requires perhaps even a little bit more. And then, as far as I know, the state of the art is something like 100 qubits at the moment. So, any other questions at this stage? I try to take a look on the chat. Actually, it's just sometimes difficult. Just keep switching between the presentation and the chat. So basically,
don't worry, I'll read them out as they come through. But no, there's no other questions at the moment. Greg says thank you.
Awesome, cool. So you can just interrupt me anytime and then just ask your question. I guess that's the most interactive way. Cool. So basically, Fabric based on elliptic curve and elliptic curve digital signature algorithm. You can choose like 3 different algorithms, including different key size in the certificate authorities, but all 3 are actually elliptic curve digital signature. So there's no exception. So that's signing, and then one more stuff that is basically you have to know on Hyperledger Fabric. That's the basic PKI, public key infrastructure concepts, and it starts with certificate authorities. So basically, if we just look back at this original picture, it looks that way. That so digital signature supposes somehow that Bob has the public key of Alice, and then Bob should actually get this public key from a trusted source. Otherwise, the whole system can have problems and man-in-the-middle attacks. So this public key, we have to make sure that this public key comes really from Alice in the standard digital signature algorithms. So one way of having such a trusted public key exchange is to have something as a certificate authority, and then basically certificate authority distributes public keys for both Alice and Bob, or gems in this sense. So basically certificate authorities signs somehow these public keys. So if we have the public keys from, I mean, if Alice has the private key from gem signed by the certificate authority, or gem has the private key from Alice signed by the certificate authorities, then they can be both sure that this public key is from a valid source, is from a valid authority. So that's certificate authority. And then we get something as an X509 certificate. Basically, X509 certificate is a standard document format for the whole public key infrastructure. So this is how it looks like. We get something as, so it's basically a public key. It can be actually a private key as well. There are many X509 certificates, but in our example, it is usually a public key which is signed by a certificate authority. So this is how it looks like. We get a lot of metadata here, but basically the two important stuffs are, we got something as an issuer, and then in our example, issuer is actually a Hyperledger Fabric certificate authority. So usually you get your certificates from, I don't know, GoDaddy or some other sources, but this is important. Then in Hyperledger Fabric, we get Hyperledger Fabric certificate authorities that are used in most of the cases, and your certificates and public keys are signed by this certificate authority. And usually it's in terms of X509 certificates. So what we got here, we got some metadata, some signature algorithm, and then we get the issuer. So the issuer is actually one certificate authority, which is somehow associated to the org1.example.com. And then basically this is the certificate authority.org1.example.com. It is usually, if you work with like fabric samples, this is the usual setup, for instance, for your whole structure and for the certificate authorities, for your certificate authorities. So this is basically the issuer, which is the certificate authority, and we got a subject, and then subject is somebody having basically a public key, or somebody's public key basically. So at this example, we got here a peer. So we got a peer certificate basically, which is the peer0.org1.example.com. And then it is again something which is usual in fabric samples. So we see that this is a peer certificate. It is actually a peer identity certificate. We can see somewhere that this is actually used for digital signature. So again, X509 is basically a general document format that can have many different versions. So you can have something as digital signature keys, as keys for use for TLS, for keys using encryption, and so on and so on. And usually in key usage, and I think in one more field, you find what kind of a key is that exactly. So in this example, this is a this key is used for digital signature. And in the subject, we can see in the organization unit that this is a peer key. So this key is actually used for identifying something as a peer identity. And it is signed, or it is issued by an issuer, which is basically our certificate authority. Let me have some, I don't know if you guys are familiar with that. I have here a very simple organization. Actually, I do not even have something as a certificate authority. And the reason is for that, because you have basically one tool, which is called CryptoGen. and CryptoGen is used to generate for you test certificates. So in this very simple example, if you ever worked with like Hyperledger Fabric, you get basically the crypto config, and under crypto config, you find in a structured way all of your certificate. So if I just go inside and then I just take a look like the sign cert here, and let me just find some open SSL. So if I take a look on one certificate, then it should look that way, that I can take a look in the content of this certificate, and basically we should see something similar that I show you on the screen. Okay, so basically this is the content of a Hyperledger Fabric certificate. It was generated actually by the CryptoGen, so it wasn't directly. It's like a simulated Hyperledger Fabric certificate authority certificate, and we got here the information like the issuer. It's a certificate authority which is simulated in this case, but usually you should have this kind of certificate authority in your Hyperledger Fabric network. Yeah, questions?
Daniel, yeah, Greg is asking, from the example you were showing, I guess, is it true that two orgs with two peers each creates almost 100 certificates? Or was that just...
Perhaps not 100, but many, yeah. So if you ever take a look on basically a crypto config folder, then you find a lot of certificates. They are not always individual certificates, but there are many, yeah.
Okay.
So that's the reason you should be aware of this whole certificate stuff if you work with Hyperledger Fabric infrastructure, yeah. So you see the issuer, that's the issuer here. You see actually the validity. It's like theoretically, if you generate these certificates with CryptoGen, then you get the validity for 10 years, which is not very practical in production scenarios. And then if you generate for CryptoGen, it can't really be revoked, for instance. But anyway, so this is the validity of your certificate. You get a subject. So this is the subject of your certificate. You see that this is a peer. In organization unit, you usually find the different versions of your certificate. It can be a peer. Then you see in organization unit, that's a peer. It can be an ordering service. Then you see that's an ordering service. It can be an administrator of an organization. Then you see here admin. And then the fourth one is, if I'm not mistaken, that client. Client is somebody wanting to send transactions on the network. I guess that's the fourth one. And it's reflected in the organization unit. And in CN, you see basically so that's your peer basically. So this is a peer identity certificate for this peer. And then, I mean, the rest is not Fabric specific. You find something like, I guess this is the algorithm that you use. You got one elliptic curve digital signature algorithm, and then you get a hash function as well. So basically it looks that way, that you get like a public key, you should hash it together and sign it with your certificate authority. So you get like one hash function and one elliptic curve digital signature algorithm. So these are the pairs, and you find here some more information on the elliptic curve that you're exactly using. One of the most important, actually, the key usage. So you can see here if this key is used for digital signature, for encryption. I mean, there's no encryption in Fabric, but generally, if you take a look on X509 certificate, you might see that that's used actually for encryption. You find here TLS, if it's used for TLS, and so on. And then I guess that's your signature somehow, basically. Okay, so that's how an X509 certificate look like. And then, so based on public keys, X509 certificates, we got something as a public key infrastructure. And this is how generally public key infrastructure look like. So basically what we have somehow, I mean, the basic idea is, and that's the basic idea of Fabric as well. So I generate somehow a key pair. I generate a public key and a private key. And basically what I want to do, I want to share somehow my public key in a way that basically everybody knows that this public key is related to me. So it's, if I sign something with my private key, then everybody can check that really, I mean, this was signed by me. But for that, it's required that this public key is somehow trusted. So if this public key is not trusted, you can have something as a man-in-the-middle attack, which should be avoided. So what's happening here, we generate a key pair, usually, that's on a client, for instance. I mean, it depends on the infrastructure, but in most cases, that's on your client. And we get something as a certificate signing request. So we send this public key to the certificate authority and say, hey, this is my public key. Everybody should trust me, so sign this public key for me. And if this public key is signed, basically based on the signed public key, I mean, the signed certificate authority is a signed public key, we generate an X509 certificate. And this X509 certificate can be actually distributed to anybody. And then anybody takes a look on that X509 certificate, finds my public key inside, and then finds the signature of a certificate authority and knows that, hey, this guy can be trusted. I mean, if I see basically a transaction or anything which was signed by the private key, then I know that this is related to the public key. And I know that this public key is related to that guy, really. I mean, I can trust on the public key as far as I trust in the certificate authority, basically. Okay.
Yeah, Greg just had not a question, but a comment that he said he believes that that PKI is also how the Bitcoin network works, in his opinion.
Not exactly. So one of the difference between so you get digital signature. You get digital signature in elliptical digital signature in the Bitcoin network. That's correct. But you don't have certificate authorities. So the point, I mean, one of the big differences between like Bitcoin public networks and consortium networks like Hyperledger Fabric is that this is actually a certificate. This is a semi-trusted networks. So we have something which is which certifies my public key. In Bitcoin, I can generate anytime a public and private key pair, and I can use it with the network, but this is a fully open permissionless network, and nobody certifies my public key. So I can generate as I want, but there's no something, it's a total trustless system. So there's no like trust way of trusting my public key. The point is behind Hyperledger Fabric that this is a consortium network, and it's like you can build up like semi-trusted scenarios. So it means basically there can be more centralized components like certificate authorities, and we have to trust in the public keys only that are signed by the certificate authority. So this is like a consortium and permissioned network. And one big difference between like Bitcoin and Hyperledger Fabric in terms of keys and signatures is that in Hyperledger Fabric, these signatures must be trusted somehow. And this must be trusted is exactly how the permission blockchain is built up.
Yeah, he just clarified that he meant the public and private key pairs.
Yeah, exactly. I mean, you get absolutely public and private key pairs, and they work pretty much similarly in this way with elliptic curve digital signature algorithms than here in Fabric. Here the big difference is that there must be some permissions built in the system, and the permissions are built in most with the way of having like certificate authorities signing your public keys and trusting only in the signed public keys. Yeah, you're absolutely right. I mean, the keys are exactly the same as in Bitcoin. So the core digital algorithm is absolutely the same. You're absolutely right. Yeah. So then the next slide is, so again, conceptually, what we got here, if we just take a look on, let's just compare like Bitcoin and Hyperledger Fabric, just from a conceptual point of view. So the point is, with Bitcoin, you get like peers running your blockchain, or clients, we can call it as Bitcoin clients. And basically it looks that way, everybody can run a peer. So basically, if I download Bitcoin Core, I can synchronize my network. It's gonna take a while, but anyway, I can attach to the network and I can do whatever I want, whatever I can. So this is an open permission blockchain. Of course, I mean, there's a limited resource in the system, that's computation at the moment, which might not be unlucky. So I can do anything in the network up to my computation power, let me put it that way. But this is like an open permission network. The major idea behind Hyperledger Fabric, that this is pretty strongly a consortium network. So it means you don't have the peers, the clients, just, I mean, all over the world running by anybody, but you get here something as institutes. Institutes that basically know each other. They don't necessarily trust fully in each other, but at least usually we say that, hey, these are like, I don't know, like financial institutes wanting to build up kind of a network. And we get like these 5 financial institutes. This is just 4, but anyway, 4 financial institutes in the network, and they wanting to cooperate, and they wanting to share information, and they at least a little bit trust each other, not fully trust, but at least a little bit trust. And anybody wanting to join to the network is not such an easy process. So if I want to join to the network, it's not, doesn't look like as in Bitcoin, then I just download some kind of a client, synchronized by blockchain and rock and roll. But basically, it has to be allowed by all members or majority of the members of the consortium. So this is something which means this is a consortium permission network. And then from another point of view, that's from the infrastructure point of view, if you take a look on the client, basically in Bitcoin, it looks that way. Anybody can basically generate a public-private key pairs and can start to use the network. So there's no limit on that. But basically, it doesn't look like in Hyperledger Fabric. Hyperledger is a let me put it that way, private permission network. Actually, it's a consortium one, but anyway. So
Greg
basically,
had a
it looks
comment
that way.
that,
if you just generate a key pair.
Greg had a comment that they don't trust each other; they trust the consortium.
Yeah. So let me put it that way.
Of.
There's more trust in the system than in Bitcoin, because you know, I mean, in Bitcoin, you don't want to trust anybody. You don't want to know anybody. In a consortium network, I would say there's a little bit more trust in other institutions as well, because the point is basically that, so usually there's you don't expect from another organization to attack the whole network. Okay, so basically it looks that way. In Bitcoin, nobody knows where's your client, where's your node. Basically, if you have like a 5-node organization in a consortium network, at least they know each other, so they are not anonymous. So if like one organization try to attack the network, then the others will recognize it, will know exactly who's the guy behind that institution. So what they can do, they can have something as like, legal actions, for instance, against this guy. So I would say there's a little bit more trust for other participants in the consortium network than in Bitcoin. Okay, that's all.
Yeah, and Greg also had a comment that if one trusts the Linux Foundation, they should trust the Fabric Consortia.
I wouldn't say it because it looks that way, that you find the code in GitHub. So of course you have to trust the code, but this is a totally open source project. So what you can do, you can download the code and then you can review it, byte to byte, just like as in any kind of a public blockchain network. So you don't have to trust the Linux Foundation. You don't have to trust even the code. You can download and make your own investigation. Or if you don't have the competence making that byte to byte investigation, you can just contract some professional developers to do that on behalf of you. So I would say you don't have to trust the Linux Foundation.
And György had a comment that one of the big differences, I guess, is less with trust, and there's censorship resistance in Bitcoin and Ethereum, but there's no such thing really in consortium networks.
So censorship resistance depends actually a little bit. It's a more difficult question, I would say. It's like we can have some censorship resistance, but it depends on your algorithm, actually, like on your quorum algorithm. So what you can do, for instance, if you have censorship resistance in Hyperledger Fabric depends on the ordering service, basically. So if you have your full ordering service running with one actually, let me just think it over. These are difficult questions, but so basically in Hyperledger Fabric, your censorship resistance depends on how much your endorsement policy is decentralized and how much your ordering service is decentralized. You can build up actually pretty centralized systems with Hyperledger Fabric, but let me just imagine if both your endorsement policy and your ordering service are fully decentralized, then it means that let me say we vote for a transaction with a quorum of these 5 organizations. So if 3 of the organizations says yes, then your transaction is valid in very simple terms. And if at least 3 organization blocks your transaction, then your transaction is blocked. Okay. So it means it has some centralization, but some decentralization as well. So it's less censorship resistance than Bitcoin, but it not necessarily look that way, that one organization decides if your transaction is valid or not. If that makes sense.
Greg said there's no orders in Bitcoin, and Fabric has changed order algos from Kafka to Raft, for instance.
Yeah, that's right. So that's not much the axis policy, but you get actually. So Hyperledger Fabric has like a several stage consensus mechanism. I have one slide about if you're interested, but it's basically a several stage consensus mechanism. So it is totally different from the consensus mechanism of Bitcoin. But yeah, one part is the ordering service. So actually consensus, how much your consensus is decentralized based on 2 things. One is your endorsement policy, and the second one is the ordering service. And then in both items you can find or you can configure in many different ways. And for orders, basically you can have Kafka or Raft or even solo consensus mechanism. And actually, so the difference is between that. Solo is just for development and for one node, basically. Raft is simple to configure, but it's just fault tolerant. not Byzantine fault tolerant. So if your nodes are hacked, then basically that's a problem. In Kafka, there can be configured something as Byzantine fault tolerant consensus mechanisms as well, up to one Byzantine failure error. But the point is that Kafka is basically difficult to configure. But let me put it that way, that basically the attack model for a consortium network is pretty different from an attack model of Bitcoin. So like if you want to attack Bitcoin, you have one scarce resource. That scarce resource is the computation. So if you want to attack the Bitcoin network, you need a lot of computation. In consortium network, your scarce resource is basically the identity. So these institutes have actually an identity behind, and only institutes or actors with identity can participate somehow the network. So if you want to attack a consortium network, what you have to do is basically steal an identity. So that basically means that you have to break into one or two such organizations. So you have to hack the organization IT, and then you have the chance of somehow attacking the network. But if you just imagine that these institutes are like I don't know, banks or financial institutes, usually it is not so simple to break into the IT of such an institute. So, did I answer all of the questions?
Yes, I believe you did. And yeah, so going forward, if there's anything that people want said, just ask it in the form of a question and I'll ask it. Otherwise, I'll just say, just so we don't eat up too much of your time.
Okay, awesome. So what we want to build up actually based on public-private key infrastructure is some kind of an access control. And there are several items where you find access control in Hyperledger Fabric. Again, this is a permission network. So like, for instance, you got something as network items, components like peers and orderers. And there are some rules that a peer can communicate with an orderer just in certain situations. Or there are some examples that an orderer can communicate with a peer, again, in some certain situations. And then in terms of user, I mean, regarding users as well, you can have actually policies. So like your user can communicate with your peer. That is again access control, and you can have something as basically roles of your user. So you can say that, hey, this is an administrator role, so it can actually communicate with your network as an administrator, or this is a normal user basically, and normal user can communicate with your network as a normal user. And then the wide idea, or not so wide, but the difficult idea is that all of the Hyperledger Fabric access control is built up with public key infrastructure. So that's the reason why it's so complicated. So basically it looks that way, or it can look that way. One way of doing this is like you want to be sure that the peer communicates with the orderer, and then basically a message comes from your peer if it communicates with the orderer. So one way of doing this is to put your public key, to put the public key of your peer somehow somewhere in your ordering service into a folder. We can call it MSP as well. And then basically it means if there's a communication way signed by the private key and we get the public key here, and we know that this public key is related to the peer, then we know basically that the peer communicates with us and not some other actor. Okay. It's basically the same if an ordering service wants to communicate with a peer, we store somehow the public key of the ordering service, and then we know actually that the ordering service communicates with us. And basically it's the same for user as well. So if a user wants to communicate with us, then we can see, or we can say that, hey, we store the public key of the user. So anytime a user signs a transaction or signs even a communication, signs even a message, then basically we know that this is our user. If there's an administrator, then what we can do, hey, we store the public key of our user, of our administrator user, somewhere in this peer. We can have a folder We can call it even as membership service provider. And then basically, if a user signs anything, then we know, hey, this is an administrator user, and we can define some extra rights for our administrator. Okay, so this is the easy way. It can be realized in a more complicated way as well. Because I said, hey, if we want to know that this is our user, this is our admin user, we can store the public key of our user. But basically, it can be built up in a more complicated way as well. We don't have to store the public key of our user because actually the user with the signing can send not just the public key, but somehow the whole certificate, X509 certificate as well. And if we know that this public key is basically in a certificate that was signed by a certificate authority that we trust in, then we can say, hey, this is an administrator. We give for this user extra rights. So if we just take a look, basically, I don't know if I find an admin certs. These are certificate authority certs, but like we get like users. If you ever take a look on basically on this crypto config stuff, we get something as a user. And in user, there's like, I think sign cert should be, so this should be actually a certificate which is related to an administrator. So basically it means if somebody signs basically any kind of transaction and then there's an X509 certificate somehow this way, then we know that this is really an administrator. It was a little bit, I guess, fuzzy what I was saying, but let me take a look. And I'm just closing this chat because otherwise we can't see actually the screen. So let me just copy actually my OpenSSL stuff. So this is our OpenSSL command. I have to take a look. So, and just 1 second. And let me just do some copy paste magic. And basically my copy paste doesn't work. Sorry for that. And it's because the zoom is a little bit big. So just give me a second. This is the, typical demonstration stuff. I have to take back the zoom. And let me just make some clean. And just some paste, So this is just the usual demonstration effect, but basically it looks that way, that I have here an administrator certificate, and an administrator certificate looks that way, that I get an issuer. So basically I need to have an issuer. That's the basis of the trust. So not anybody can be actually an administrator in my network, but only somebody having basically an X509 certificate, or basically a key pair, for that the public key is actually signed by the certificate authority with some actually meta attributes as well. So we get here the certificate authority that we trust. That's our certificate authority. And we got here our subject. And in subject, you find two information. One is the admin. So simply put, this means that this is our administration. administrator. So anybody seeing actually this signature with this kind of a certificate knows that basically this was done by an admin. And then this is actually the name of the admin, and we can have some more information like I mean, the organization and stuff like that. But this is the major idea for access control. So if we want to have a role of users or a role of any kind of network component, and role means that members of the role having like different rights of doing things, then everything looks that way. Then there should be actually a public-private key pair, and then the public key should be signed by a trusted certificate authorities, and the trusted certificate authority should say as well that, hey, this public key is related to a certain role. Okay, so anything which is an access control, which is right of user, access of peers, access of infrastructure components, is built up with public-private key infrastructure.
Hey, Daniel, Greg wanted asked, what's the syntax of the OpenSSL command you use?
Oh, yeah, sorry. It's not so complicated. It's just OpenSSL x509 -in. Then you have the certificate name and minus text. So this is actually the command. And then this is the certificate name in it. Okay. So based on this stuff, we get the membership service provider. I mean, if you heard about like Hyperledger Fabric, you probably heard that. So membership service provider is this lot of keys collected together, having access to the components to each other. Okay, so if you just take a look in this crypto config folder, it has actually a lot of keys, not just membership service providers, but basically if you just go to like to one peer, then under one peer you find the MSP folder. And the MSP folder is the local membership service provider.
Daniel, your screen went away.
Sorry?
Did you intend to turn your screen off?
No.
Oh, it's not being shared anymore.
Okay. I mean, not okay, but let me take a look. I don't know. It's just vanished somehow. My Zoom. Okay. Just a second. Awesome. So is it better now?
Yeah, we can see it now.
So if you just take a look on your crypto config folder and you go to like one peer, and this is one peer, under one peer, this is like one component. You see like the MSP folder. And MSP folder is actually this bunch of keys and certificates related to the local who's who in the network, who's who, and what rights or access can do anything on the local peer stuffs. So basically you have here like administrator certs. These are the signed, these are the certificate authority sets that we trust in. This is the identity key for your peer, for instance, and this is the public key signed by your certificate authority as a signed certificates. And we get something as TLS. We can configure like TLS and secure connection as well, and it's getting even more complicated. Okay, but the point is basically that membership service provider is really this lot of keys giving access for the who's who in your network. Okay, so I don't go very much into the details. I don't know if you ever seen it, just like in 5 minutes, covering some Hyperledger Fabric, very Hyperledger Fabric specific tasks as well. So usually it looks that way. You have something as to generate, and then the reason why I can't do this is because here. So basically, you have usually in the different test networks, if you use with like Fabric samples, you get basically a generate script, and generate uses one built-in tool that's Cryptogen, and Cryptogen generates for you based on your crypto config YAML some default certificates for development and for testing reasons. So it's just much easier to start basically your network. But this is not really production ready. If you just take a look on config, it looks that way that, sorry, this is the wrong config. This is the good config. So it looks that way. We got like ordering service. We generate like identity certificates for the ordering service components. We generate like identity certificates and TLS certificates for our peers. And we get one organization as well. And then we generate some users as well for the organization. It's like standard users and administrators as well. So I would not necessarily go more into the details because we are running out of time. This is what I covered from Hyperledger Fabric basis. Let me say, if you guys have any questions, I will try to answer. So if you're not very much familiar with Hyperledger Fabric, it was probably a difficult presentation. This is like Hyperledger Fabric here. So it's like consortium blockchain networks. You get different components on your network, like peers, ordering service, certificate authorities. So everything which is one client, one node with Bitcoin that's distributed in a fully microservice architecture, having a lot of stuffs here basically. So is there any questions? Or if you guys want to know, I can plunge a little bit more into the details into general Hyperledger Fabric introduction. But it wasn't really planned actually by me for today, but I can do it anytime, nevertheless. So let me just take a look. If we get something, I'm just stop sharing because I just want to go to YouTube if we might have some questions there. But it's always difficult. Yeah. So there's one question: how does Hyperledger Fabric 2 Plus version supports Ubuntu 20? It's a good question. It should actually you find something as basically as an installation guide on Hyperledger Fabric. It's actually one script that you have to run. It downloads all of your components, containers, and then installs your Fabric samples, where you can find stuffs like that, like for generated configs and other stuffs. But it might be actually an old question. I don't know. So, any more questions? So if there's no more question, then that was actually the Hyperledger Fabric meetup, Budapest meetup for today, or slowly for tonight. So I would like to thank you very much for György, the presentation, and I would like to thank you very much the participation of all of the participants. And then that was all for today.
Awesome. I thank you for the opportunity.
Thanks for the great questions, everybody.
Okay, thank you. Thanks. Bye.